We are solving chapter 1 side problems. This is page 4. The chapter 1 all problems will about angles. So in an ABC obtuse angle, and there is a connection 2 times ABC is 3 times XYZ. What types angle is XYZ? So to start with this one, so we need to know the definition of obtuse angle. So before we start, the obtuse angle definition involves between 90 and 190 degree and 180 degree. What other angles do we have? Ava, do you know that?
Well, besides obtuse angles, you can have right angles and acute angles.
Okay, then how do we start this one? Should we say, if I say this ABC is 3 alpha, how much value should I give XYZ?
You should give it 2 alpha. That way they are both common.
Okay, good. Then if ABC is obtuse angle, means the value of ABC between 90 degree and 180 degree. Then the value of 3 alpha would be between 90 and 280. What about just alpha would be?
It would be you would divide everything by 3. It would be between 30 degrees and 60 degrees.
So then what are we looking for? We are looking for XYZ, right? The value of XYZ. What degree between?
Well,
so
it would be 2 alpha.
2 alpha. How do? We multiply by 2. We multiply by 2 everything. So 60, 2 alpha, and 120. So degree and degree. Then what will be our conclusion?
Well, as you can see, it could be an acute angle, it could be a right angle, or it could even be an obtuse angle.
Yep, that is correct. All 3 are applicable. So the next problem, page 5, side problem, it is asking something about vertical angles. So this is vertical angles, means if 2 angles, this is, let's say, alpha 1, alpha 2, and alpha 3. Alpha 1 and alpha 3, they are vertical angles. Now we are going to understand why alpha 1 equals to alpha 3, AOB and COD. Okay, where should I start, Ava, to do this proof?
Well, you can start by noting that alpha 1 plus alpha 2, as they form a straight line, it equals 180 degrees.
Then is there any other 180 degree do you see? Is there any 2 supplementary angles? Yeah.
Yes, I do actually. Alpha 3 and then alpha 4 would also, alpha 2 and alpha 3.
Alpha 2 plus alpha 3 is also 180 degree. Then can we say that alpha 1 equals to alpha 2, that equals to alpha 2 plus alpha 3? How do we get, do you see any conclusion from here?
Yes, you could cancel out the alpha 2 from each side, and then you get alpha 1 is equal to alpha 3.
Which is QED. That's the required proof, right? Then we got this one, alpha 1 and alpha 3. They are vertical angles and they are equal each other. Page 8, another side problem from brilliant.org. Let me just make a bigger this one. So where is the, so it's a two diagram, which is 30 degree, we can see 230 degrees, and we need to find x. But what information will be useful? Eva?
Well,
Yep.
we could note that there would be 90 degrees between, you see where the pencil is yellow, it forms 90 degrees.
Let's say, let me just get straight this one and this one. You mean that
Yeah.
and yeah, let's make this identify. That's a good way to see that. This is going to be 90 degree. That will be very useful, 90 degree and 90 degree. So what other useful information we can think of? And I already underlined this one.
Oh, well, that is, it is attached to an isosceles triangle, which means that the two side lengths must be equal.
This one and this one, they are equal. And do we see any other angles, useful angle that will help us to move forward?
Well, yes, for the two isosceles triangles, we could find the other two angles. It would be 180 minus 30 divided by 2.
Which is
75
75
degrees.
75 degree, and 75 degree. So we are almost here. What would be the final finishing point equation? Would that be here, right? There's a whole thing add up to what?
360 degrees, as it's a circle.
75 degree, 90 degree, 90 degree, and x is 360 degree. Then the value of x would be, this is 150 degree.
And then 90 plus 90 is 180.
90 plus 360. Then x would be just a supplement of 150, which is
30
degree.
degrees.
Yep, that's our answer. That's understandable, right? All the points. Okay.
Yes.
Great. Let's see. These are page 10 side problem. There is an angle ABC and two bisects. Let's first of all visualize the situation. Here is the visualization for one. So if I say it's ABC, this is B, this is A, this is C, and I'm going to connect two angle bisect, right? Angle bisects of B and C and meet at
point I.
Let's put this small b and small b. Let's put this one small c and small c. And we have and big A here. And let's say and big I. So how do we see starting point of this problem, Eva?
Well, you could form two equations because we have a smaller triangle within a bigger triangle. For the smaller triangle, you could say B plus C plus I is equal to 180 degrees.
Or the smaller triangle means this one. We can write B plus C plus I is 180 degree.
And then for the bigger triangle, it would be 2B plus 2C plus 56 degrees is also equal to 180.
Oh, this A is already giving, right? 56. Also 180 degree. Then how do we handle these two equations?
Well, you could do one out of two ways. Do you want to just multiply the first by 2 and then cancel out?
Yes, let's multiply -2.
Yeah, -2. -2b minus 2c minus 2i is -360.
Then you add them together.
Well, the b's and the c's cancel out. It's 56 minus 2i is equal to -180.
Then 2i would be just 90 plus 28. I divided everything and it's going to be 118 degree. So this is 118 degree. Yep, that's good. And I would like to just give you a general formula for two types of angle bisect. One of them is if two angle connect inside, so two angle bisect connect inside, it's going to be obtuse, which is going to be 90 plus half of the top angle. Okay, let's put this one. Then what if they two exterior angle bisect outside? This time would be acute angle, which is less than 90 degree, but how much less than? That's this. It's useful formula, Eva, for if they connect inside, 90 plus A over 2. If connect outside, 2 angle bisect, 90 minus A over 2.
That's very useful.
Proof will be what you just mentioned, the writing to equation. Both proof will come from that your way. So that's good. So let's see, Eva, how do we approach this page 11 side problem?
I do not have annotating privileges, but I will just explain.
Okay, let me give you. There you go.
Okay.
You can annotate.
So, in a triangle of A, B, and C, the mean of B and C is A. What that means is that B plus C over 2 is equal to A. And if we want to get rid of the 2 in the denominator, we can say that B plus C is equal to 2A. What's the value of A? Well, A plus B plus C will be equal to 180 degrees. We already know B plus C is the same as saying 2A. So we could say A plus 2A is 180 degrees, 3A is 180, and A is 60 degrees.
Okay, I think that's understandable and very clear explanation. Yep, that's good. Let's see. Then let's move to our the other side problem. As usual, when you see the problem, we encourage our students, audience, to first pause, try 1-2 minutes, maybe individual thinking time, and later watch the solution steps. So in a right triangle, I'm going to visualize this one in a right triangle, and there is a B, C, this is B and C, and then this is half, AM is a half of, okay. Then, so what's happening, there's a special property for this problem. If a right triangle and median coming from the 90 degree, then that has to be also the third one also equal each other. These three length equal each other. Now we need to draw a height. Then we are looking for, no, it's given, right? This is a H, this is H, this is, what's the angle, this angle, Eva?
40 degrees.
40 degrees. And then what's left over here?
Well, 90 plus 40 is 130. It would be 50.
50. And then I mentioned this one is also equal, right? So
yes.
Then what's the next step?
We could use the interior angle theorem, perhaps.
Which is, oh, I mean that because these two angles add up to 50, right? Or
yes.
Or we can go from here, right? This is 130.
Yeah.
And then this, if this is x and x.
Well, x and x would be equal to 50 together, so 25.
Yep, that's right. This is going to be 25 degree. I think this information is useful. If 90 degree and median and these three sides goes together so that they are equal. So. Then another side problem on page 16, chapter 1.
Okay, so for this problem, first we should note that there are some equal sides here. So BD is equal to AE. That means this is equal to that. AD is equal to EC. This is equal to that. So if we represent, say, BD and AE as having side length A, and then DA and EC as having side length B, we get that both of these sides of the triangle are A plus B, which means they must be the same, meaning that this is an isosceles triangle. Thus, we know, as this is an isosceles triangle, that this must also be equal to 35 degrees. Now, how do we solve for our given angle? Well, let's use the interior angle theorem. How about that, Professor?
Yes, that's good. So do you notice something, Eva? So because you put A and B, why did you put that? That will be useful for us. A, B, and AB.
Oh, Professor, we can solve for DA. We could solve for this by using 180 minus 35 plus 35. 180 minus 70, that is equal to 110. Oh, and then to find, this is the angle we need to find. We use the interior angle theorem. We say it's equal to 110 degrees plus 25 degrees, which is...
Oh, I see. That is very good. One exterior angle. Okay, that's very useful, Eva. So you mean that, so this one, right? This angle, right? One exterior angle is equal to
those two interior angles.
That is very good. So it's kind of, it reduces one steps. So, and then I see that you got this one is as 110 plus 25, which is 135. Yep, that is great. So that's end of our chapter 1 problem.